Good morning. Today we discuss a few problems from the year 2018 May June from the topic permutation and combination. The first question is 9 people are to be divided into a group of 4, a group of 3 and a group of 2. In how many ways can this be done? So the question says that 9 people total, we have 9 people. These 9 people are to be divided into a group of 4, a group of 3 and a group of 2. So the total number is 9. Total we have 9 people. And here we need to make how many groups? 3 groups. Let's take group 1. Group 1. Group 1 must have 4 members. How many members for group 1? 4 members. From where these 4 members to be chosen? From out of 9 members. So 4 members can be chosen from total of 9 members. So in how many ways it can be chosen? In 9C4 ways. Yes? Okay. Now let's go for the second group. Second group consists of 3 members. From how many members this 3 should be chosen? Is it 9? No, it is not 9 because already in group 1, 4 members are chosen. So remaining, how many members are remaining? How many members are remaining here? We have out of 9, 4 members chosen. So remaining 5. So from these 5 members, you have to choose 3 in 5C 3 ways. Okay, so remaining, how many members are there remaining? Yes, there are 2 members. So out of 5, 3 members were chosen here, remaining 2. Now group 3 to be made with 2 members. Yes, so there are 2 people remaining and 2 members to be chosen in 2C 2 ways. Okay, so we can say total number of selections is first group 9C4 and second group 5C3 and third group 2C2, which is equal to 9C4 is 126 into 5C3 is 10 into 2C2 is 1. So we get it as 1260 as result. Okay. Another question. How many different arrangements are there of the 11 letters in the word Mississippi? So in Mississippi, how many letters are there? 11 letters are there. How many different arrangements? So from this you can understand it is permutation. Okay. So how many different arrangements are there of the 11 letters in the word Mississippi? So total number of arrangements is always, total number of arrangements is, as there are 11 letters, it's 11 factorial. Okay. Now you need to check whether any letter or alphabet repeating. Do you find repeating alphabets? Yes. I repeats how many times? 4 times. So divided by 4 factorial. into S repeats 4 times. So 4 factorial into, then P repeat twice. So 2 factorial. We get it as 34,650 as answer. Okay. Another question. 2 letters are chosen at random from the 11 letters in the word Mississippi. Find the probability that these 2 letters are the same. So check the question. 2 letters are chosen at random from the 11 letters in the word Mississippi. Find the probability that these 2 letters are the same. Okay, so let's see. So we have 11 letters. So which are the 2 letters can be chosen here, because we want 2 letters are same. If we want 2 letters are same, it can be either S or I or P. We cannot use EM for this question. So here we required the probability of 2 letters are same. That means both are yes, or probability of both are I, or probability of both are P. That is meant by 2 letters are chosen and both of them are same. Now let's check. Suppose we are going to choose this one, okay? That means probability of first one is yes and second one is also yes. So what is the probability of yes here? Yeah, you could find totally 4 yes out of 11 letters. So probability of first yes is 4 over 11 times, what's the probability of second yes? Is it 4 over 11? No, because already one yes is chosen here. So the number of yes reduced to 3 over, there were 11 letters in total, but already one yes is chosen here. So the number of total letters reduced to 10. So we get this answer as 12 by 110. That is the probability of 2 yeses are chosen. What if both are i's? Which is probability of I into probability of I. What's the probability of I here? Total we have 4 i's out of 11. So it is 4 out of 11 times, what's the probability of second I? Yeah, it's similar to yes, it is 3 out of 10. So we get it as 12 divided by 110. Now, what if both are p's? So we get it as probability of p and probability of p, which is equal to probability of p. We have only 2 p's out of 11. So the first p has a probability of 2 over 11 times. So what is the probability of second p? Already 1 is chosen here. So only 1 is remaining. So 1 over 10. We get it as 2 divided by 110. So what will be our probability? So we'll write it as probability of event. Our event is both are same. It can be either both are yes, or both are I, or both are P, which is 12 by 110, or probability of both are i's, 12 by 110, or probability of both are p's, 2 by 110, which is equal to 12 plus 12 plus 2, 26 over 110, or 13 over 55 as a result. The same question can be done in another way. See, there are totally 11 letters. So, what is the total number of selection? Total number of selection. Total number of selection. So here we use combination or permutation to answer, and as it is selection we use combination. You see, we have to select 2 letters out of 11. So total number of selection is 11C2, which is 55. Okay, now we are going to select 2 letters, they are of the same. Okay, so if to selection of 2 yes, what will be the selection of 2 yes? Selection of 2 yes. So totally we have 4 yes, and from that 2 should be selected. So it is 4C2, which is 6. Then what if you select 2 i's? There are 4 i's, out of that 2 should be selected. So that is also 4C2, which is 6. If you select 2 p's, p and p, what we get? We have 2 p's and 2 should be selected. So it is 2C2, which is 1. So what is the selection of either 2 yes or 2 i's or 2 p's? It's nothing but 6 plus 6 plus 1, which is 13. So the probability of our event is favorable is 13 divided by total selection is 55 as answer. So you can choose any of these methods. Another question, find the number of different ways that 5 boys and 6 girls can stand in a row if all the boys stand together and all the girls stand together. Okay, so here we have 5 boys and 6 girls. So we have 5 boys and 6 girls stand in a row. That means there are 11 members. If all the boys stand together, so here the condition is all the boys stand together, and also all the 6 girls stand together, like all the 5 boys, B1, B2, B3, B4, B5, all the 5 boys stand together and all the 6 girls stand together, G4, G5 and G6. So our question is find the number of different ways for this to happen. So just rewind, recall our previous classes and find out what can be done here. So in such case we have discussed about the arrangement of being together, isn't it? So let's consider this as one group and this one as another group. So totally how many groups are there? Two groups. It can be arranged in 2 factorial ways times. Now let's look the first group. In first group we have totally 5 members, can be arranged in 5 factorial ways times. When you look at the second group, there we have 6 members, can be arranged in 6 factorial ways, so that our final answer will be 172,800. Okay, another question. Find the number of different ways that 5 boys and 6 girls can stand in a row if no boys stand next to another boy. So there are totally 5 boys, totally 5 boys and 6 girls. If no boys stand next to another boy. See, this same topic we discussed in our previous classes, but in the way of no two boys. We discussed the topic no twos, no two boys, or no two vowels, no two consonants. Just recall that concept. Same thing to be done here also. So whenever we discuss about no two items, already we discussed arrange the others first. Here we want no two boys. If no boys stand to next another boy means no two boys. So here our question is dealt with no two boys. That means arrange the others. Others means girls. So arrange the girls first. Girl 1, girl 2, girl 3, girl 4 and girl 5. Of course 6 are there. Girl 6. So we could find 1, 2, 3, 4, 5, 6, 7 places for boys. So when you arrange these girls, we have 6 girls can be arranged in how many ways? 6 factorial ways times. Now look at the boys. There are 5 boys and 5 boys have how many places? 7 places. Okay, so 5 boys to be arranged in 7 places. In what way? Yes, 7 P, it is P, 7 P, 5 ways, isn't it? Okay, so that our answer will be 181,440. That means 1,814,400 will be the answer. A group consists of 5 men and 2 women. Find the number of different ways that the group can stand in a line if the women are not next to each other. So this is also the similar type of question what we discussed for the previous one. So what they meant here is, if the women are not next to each other, that means no two women stand together. I hope you can do this question. So for that, pause the video, complete the work. Okay, let's go for the next question. This question says that out of a class of 8 boys, and 4 girls. A group of 7 people is chosen at random. Find the probability that the group of 7 includes one particular boy. So the question says that out of a class of 8 boys and 4 girls. So there are 8 boys and 4 girls. A group of 7 people is chosen. A group of 7 people is chosen at random. So mark the word chosen. It's not arrangement, it is chosen, it is selection. That means you can understand it is combination. So when you continue the part, find the probability that the group of 7 includes one particular boy. So see this question. Now, first itself, let us find how do we choose the 7 including one particular boy. So we need to choose 7 people. 1, 2, 3, 4, 5, 6, 7. So from these 7 members, one should be a particular boy. That means he is already selected for the group. So he is already selected for the group. That means you no need to worry about that place. So now how many places are remaining? We have 1, 2, 3, 4, 5 and 6. So there are 6 places remaining, and totally we are having 8 boys and 4 girls. That means there were 12 students. There were totally 12 students. But out of 12 students, what happened? One boy is already chosen. One boy is already selected. Isn't it? So remaining we have only 11 students. Okay, so out of 11 students, choose any 6 to fill these places. Choose any 6 to fill these places. That means 6 to be chosen to fill the 11 places. In how many ways? In 11C6 ways. Do you know 11C6 is 462. I hope you got what to do here. Let's discuss once again. We need to choose 7 people. Out of these 7 people, we need to choose a particular boy, one particular boy to be chosen always. How many selections you do doesn't matter, but one particular boy to be chosen. So he is already a part of any group. That means out of 7, one place is already filled with a boy. So remaining how many places? Only 6 places. Okay, now let's think the total number. Total there were 8 boys and 4 girls. That means total there were 12 members. But out of these 12 members, one boy is already chosen here. That means remaining we have only 11 members. That means out of 11, this is 6 places to be filled in 11C6 ways, which is 462 ways. That means 462 ways you can select a 7 grouped with one boy is included always. There is number which is known as favorable outcome. As we want the probability, we want now total number. So total number is We have totally 12 members, 8 boys and 4 girls. From 12, we need to choose 7 people. So total number of selection is 12C7, which is 792. So the probability of this selection is favorable outcome 462 divided by 792 as result. See, the same can be done in another way also. Okay, for that, let's take the total number of selection. Total number of selection, total is, as we done in the first method, it is 12C7, which is 792. Yes. So now we are going to do a selection with a particular boy is not included. We are going to make a selection with a particular boy is not included. That means you are going to select a group of 7 members with 7 boys and 4 girls. Why it is 7 boys? Because though we are having 8 boys, a boy is not included in any group. So one boy is rejected always. So we have only remaining 7 boys and 4 girls. So we have totally 11 members. From that 7 should be chosen. So it is 11C7. Okay. Therefore, what will be a particular boy included? A particular boy included will be total minus boy not included, right? Which is equal to 462. Therefore, the probability of the event is 462 divided by 792. As a result, if you simplify this, we get it as 7/12. Okay. Next question is, find the probability that the group of 7 includes at least 2 girls. So this is another condition. So here also we are going to choose 7 members. 1, 2, 3, 4, 5, 6, 7. But here the condition is there should be at least 2 girls. Okay. So what do you mean by at least 2 girls? At least 2 girls means minimum 2 girls. So it can be 2 girls or 3 girls or 4 girls. Can we go for 5 girls? No, because there were no 5 girls in our group. So at least minimum 2 girls can be 2 girls, 3 girls or 4 girls. So when you look at here, when you choose 2 girls, remaining 5 will be boys. Or if you choose 3 girls, remaining 4 will be boys. If you choose 4 girls, remaining 3 will be boys. Are you getting what is meant by this? It's very simple. We are going to choose totally 7 members. In that, at least 2 girls should be included. So what do you mean by at least 2 girls should be included? Like 1, 2, 3, 4, 5, 6, 7. Like you have to include 2 girls, or you have to include 3 girls, or you have to include 4 girls. So now, what if you include two girls? That is a minimum number. So if there are two girls, remaining five will be boys. So we get two girls and five boys. And if there are three girls, how many boys will be there? Four boys. So if there are three girls, we could find four boys. And what if there are four girls? That means all the four girls are included. So there you could find three boys are included. Now let's make these different selections. So this is our plan. Okay, so two girls out of four can be selected in 4C2 ways into five boys. It is two girls and five boys. The connective is and, that means multiplication. And five boys out of eight in 8C5 ways, which is equal to 336 ways. If it is three girls and four boys, three girls can be selected in 4C3 ways and four boys can be selected in 8C4 ways, which gives us the answer 280. And four girls, there are only four girls and all the four are selected in 4C4 ways times three boys out of eight, that means in 8C3 ways. So we get it as 56. So what is the total number of selection of at least two girls? So that is favorable. So our favorable selection is 336 plus 280 plus 56, which is equal to 672. So the probability of selecting at least two girls is favorable 672 divided by total is 792. Okay. And it can be done in another way also. Like instead of at least two girls, what can we do is from total, if you delete 0 girl or 1 girl, from total number, if you delete the selection of 0 girl or 1 girl, then what we get? We get minimum 2 girls now, isn't it? So what about 0 girl? 0 girl means 0 girl and 7 boys. That is 4C0 into 8C7, which is equal to 8. What if 1 girl? If it is 1 girl, there will be 6 boys. So that is 4C1 into 8C6. Do the calculation, we get it as 112. So what is the probability of 0 girl or 1 girl? I'm asking probability of 0 girl or 1 girl. So 0 girl or 1 girl is 112 plus 8, which is 120 out of 792. 792 is from previous, the first part. Okay. And total probability is 1. So we can say probability of at least 2 girls is total probability 1 minus probability of 0 girl and 1 girl, which is 120 divided by 792. We get it as 792 minus 120 by 792, which is 672 divided by 792 as answer. Another question. Find the number of different ways in which all 9 letters of the word mincemeat can be arranged in each of the following cases. First one is there are no restrictions. So there are no restrictions. No restriction stands for we have totally how many letters? 9 letters. So 9 letters can be arranged in 9 factorial ways. Then what is the next thing we need to check? Yes, any letter is repeating. Yes, the letter M repeat twice, so 2 factorial into the letter E also repeat twice, so 2 factorial. 9 factorial divided by 2 factorial into 2 factorial will be the answer for this question. Okay, let's see the next question. No vowel A, E, I are vowels, is next to another vowel. No vowels are next to another vowel. So our word is M, I, N, C, E, M, E, A, T. No vowels are next to another vowel. So think yourself, pause the video and do its calculation. Okay, let's go for the next one. Look at the question. 5 of the 9 letters of the word mincemeat are selected. 5 letters are selected. Okay, 5 letters are selected. Remember the word selected. Find the number of possible selections which contains exactly one M and exactly one E. So here we are going to do selection, not arrangement. We are going to do selection, that means combination. So we need to select how many letters? 5. 1, 2, 3, 4, 5. In these 5 letters, what they have meant is one M and one E should be selected. Exactly one M and one E should be selected. As it is selection, it can be selected anywhere. Okay. So one M and one E. Exactly one M and one E should be selected. Okay. So remaining how many places we have? Only 3 places. How many letters are remaining? Because we cannot use M and E further. We cannot use M and E. So because already one M and one E is chosen. Remaining we have I, N, C, A, T. So remaining we have 5 letters. And we have 3 places. Okay. So from this 5, 3 letters to be chosen. From 5, 3 letters to be chosen in 5C3 ways, which is equal to 10 as answer. Okay. So let's check the next question. It is find the number of possible selections which contain at least one M and at least one E. Find the number of possible selections which contain at least one M and at least one E. Okay, so here also let's write the counting. Let's make the counting here. At least one M and at least one E. That means minimum one M and minimum one E should be there. So totally how many M's are there in our word? 2 M's are there. There are 2 M's and 2 E in our word. Okay, so there should be minimum 1 M and minimum 1 E. Let's see. So what are the chances we can make? We can make with 1 M and 1 E. A word with 1 M and 1 E, or a word with 1 M and 2 E's. Next, what can we do? Yes, a word with 2 M and 1 E, or 2 M's and 2 E's. So these are the possible chances. So let's see the first case. So we want 1, 2, 3, 4, 5. So in this 1 M and 1 E is chosen. So remaining letters, which are the remaining letters? In previous question already we written I, N, C, A, T. Totally 5 letters are there. So 3 places to be filled in 5C 3 ways, that is 10 ways. Let's check the second one. 2, 3, 4, 5. We need to choose 1 M and 2 E's. So how many places? 2 places to be filled with INCAT. So 2 places to be filled and there are 5 letters. So it can be chosen in 5C 2 ways. That's also 10. Let's take the third case. 1, 2, 3, 4, 5. We need to choose 2 M's and 1 E. So here also 2 places to be filled out of 5. So that is 5C 2 ways. That is also 10. And let's check the last case. We need to choose 5 letters. Out of this 5, 2 M's and 2 E's are chosen. So only one place is left. There are 5 letters. So it can be filled in 5C1 ways, that is 5 ways. So totally we get 10 plus 10 plus 10 plus 5 as 35 ways. That means 35 ways you can select a 5-letter word which contain at least one M and at least one E. Thank you.